Hello viewers and welcome. This is section 2 of the Alliance paper. Section 1 is already uploaded. You can check it in the uploads, and also you can check the description for the link to download the question paper. So let's go to section 2, 50 marks. You're supposed to answer 5 questions only in this section. Question 17 reads, a cold water tap can fill a bath in 3 hours, while a hot tap can fill it in 5 hours. The drain pipe can empty the bath in 3.75 hours. The 2 taps and the drain pipes and the drain pipe are fully open for 2 hours, after which the drain pipe is closed. Part A, what fraction of the bath is filled after the first 2 hours? After the first 2 hours. So let's go to the question again. So we have the cold water tap, which can fill this bath in 3 hours. So for the cold, let me just call this a cold tap in 1 hour. So if it can fill the bath in 3 hours, so we can get the fraction of the bath that it can fill in 1 hour. So in 1 hour, this tap can fill a third of the bath. That is a fraction of the bath. Then for the hot, so for the hot tap, this one can fill the bath in 5 hours. So that means in 1 hour, it can fill 1/5 of the fifth of the bath. Then you have the drain pipe. The drain pipe, this one removes the water. It can empty the bath in 3.75 hours. So therefore, for this one, in 1 hour, it can drain 1 divided by 3.75, which is a fraction of the bath. So that is the first step. So you need to get in 1 hour what fraction will be done by the 3 of them. Now the 2 taps and the drain pipes are fully open for 2 hours. The 3 of them are open for 2 hours. So we need to get that. So all of them have the cold, which can fill a third. So now what you can get is that in 1 hour, all of them, all the 3 taps when they're running, what fraction of the bath would they fill? So all the 3 in 1 hour, the 3 taps. We have the cold water tap that fills a third of the bath. Then we have the hot, fifth. And then the drain, because it is emptying, we are going to subtract. That one can drain 1 divided by 3.75. So that means in 1 hour, all the 3 taps when they are open, they will be able to just add these fractions using a calculator. So when you add these, a third plus a fifth minus 1/3.75, this one will give 8/15. 8/15, let me see. So we have a third plus 1/5, then subtract. This is 1 divided by 3.75, 4 divided by 15. So 4 divided by 15. So that is in 1 hour. That is a fraction of the bath that the 3 of them will fill. Now they were open for 2 hours. So what about for 2 hours? What about for 2 hours? If for 1 hour, the 3 taps can fill 4/15 of the bath, what about in 2 hours? Simply need to cross multiply 2 times 4 divided by 15, and this will give 8 divided by 15. So part 2 of the question, that is part B. How many more minutes are required for the bath to be completely filled? How many more minutes? So we're going to work from the first part. The fraction that is already filled after 2 hours is 8 divided by 15. So what fraction is remaining? So we get the remaining fraction. How do you get the remaining fraction? Assuming that the tank, when the tank is full, the fraction is 1. So subtract whatever has been filled, which is 8 divided by 15. So the part that is remaining to be filled is 7/15. Now this 7/15 fraction of the bath is supposed to be filled by only the cold tap and the hot tap, because the drain pipe is closed after first 2 hours. So now we need to get in 1 hour the cold plus the hot. What fraction of the bath will they fill? And we've already indicated here the cold will fill 1/3, then the hot will fill 1/5 of the tank of the bath. And this will give, when you add them, you get this will give 8 divided by 15. So in 1 hour, both the cold and the hot taps will fill 8 divided by 15 of the bath. So what about the remaining fraction, which is 7/15? How long will it take to fill this? So we simply cross multiply here. So we'll take 7 divided by 15 times 1, then times the reciprocal of 8/15, which is 15/8. So once you work out these, you'll get 7 divided by 8. And this one is hours. So this is the time that is going to be used in order to completely fill the tank. That is after 2 hours. And you're supposed to give this one in minutes. So you simply convert 7/8 in minutes by simply multiplying it by 60. And when you multiply this one by 60, 7/8 by 60, you'll get 52.5 minutes. So that is a solution for that part. So go to part C. Given that the cold water tap delivers water at the rate of 200 centimeters cubed per second, determine the capacity of the bath in liters. The capacity of the bath in liters. So the cold water tap delivers water at this rate. So this means for 1 second, is what it means. 1 second, it delivers 200 centimeters cubed. That is what we mean by 200 centimeters cubed per second. 1 second, this one, the rate is 200 centimeters cubed. Now remember, for the cold water bath, we say that in 1 hour, it can fill 1/3 of the tank. That means in order to fill the tank, it will take 3 hours. So cold water tap will fill the tank in 3 hours. So if in 1 hour it can fill 1/3 of the tank, that means for it to completely fill the tank, it can take 3 hours. That is very important to understand. Then from there, if in 1 second it can fill 200 centimeters cubed, what about in 1 hour? So what about in 1 hour? Remember, in 1 hour, 1 hour has 3,600 seconds. So 3,600 seconds, then we multiply by 200. So now we are converting the rate from seconds to hours. So if in 1 second, it can fill 200 centimeters cubed. So in 1 hour, we'll simply multiply that by 3,600. Why? Because 1 hour is equivalent to 3,600 seconds. So this will give, when you multiply these, you'll get, this is 3,600 times 200. This will give 720,000. So 720,000 centimeters cubed. That is in 1 hour. So that is very important. Now, after getting that, that is 1 hour. And remember, we said that this tap can completely fill the tank in 3 hours. So what about 3 hours? To completely fill the tank, you simply multiply 3 times 720,000, and this will simply give, if you multiply this, so 720,000 multiplied by 3, this will give 2,160,000. So 2,160,000, 260,000 centimeters cubed. So that now will give us the capacity of the tank in liters. So this becomes the capacity, because that is the time that the cold water tap can use to completely fill the tank. So using the rate, we have got the capacity. That is the capacity of the tank. Then part 2, the rate of flow of the hot water tap, the rate of flow. And before we continue, we've not finished for the first part, because we're supposed to give that one in liters. So for you to convert this one in liters, you need to divide by 1,000. So this will give 2160. Why are we dividing this? Because 1 liter is equivalent to 1,000 centimeters cubed. So this will give 2160 liters as the capacity. So part 2, the rate of flow of the hot water tap, the rate of flow. So we need also to get the rate of flow for the hot water tap. So for hot water tap, remember up there we said that hot water tap can fill 1/5 of the bath, 1/5. So for hot water tap, this one can fill in 1 hour 1/5 of the tank. So to completely fill the tank, it will use 5 hours. That is to completely fill the tank, or fill the bath. So if in 1 hour it can fill 1/5, that is a fraction of the bath. So that means to completely fill this bath, it will take 5 hours. So for us to now get the rate, we're supposed to calculate the number of seconds. How many seconds will these 5 hours be? So in terms of seconds, because we already have the time in hours that the hot water tap can use to fill this bath, which is 5 hours. So 5 hours. So in seconds, we'll take 5 multiplied by 3,600. Why? Because 1 hour has 3,600 seconds. So this will give 18. When you multiply these, it will give you 18,000 seconds. So that is the time in seconds that the hot water tap would use to completely fill the bath. Now, since we know the capacity of the tank, we can now get the rate. The capacity is 2,160,000 centimeters cubed. And then we have the time that this hot water tap can use to fill the tank, which is 18,000 seconds. So when we divide that, we will get the answer in. So 2160 divided by 18,000. So this will give 120. This will be 120 centimeters cubed per second. That is the rate. We go to the last part. If the hot water tap is opened at 7:45 and runs for 3 hours, then the cold water tap and the drain pipe are opened, find the time when the tank will be full. So hot water tap is opened at 7:45 and runs for 3 hours. So we need to know first the fraction filled. So hot water tap, remember it is a hot water tap, can in 1 hour it fills 1/5 of the tank. So in 1 hour it fills 1/5 of the tank. That is the hot water tap. So it runs for 3 hours. So what about in 3 hours? What fraction will it have filled? So simply multiply 3 times 5, and this will give 3/5 of the tank. So after 3 hours, this is the fraction that will be filled by the hot water tap. Then the cold water tap and the drain pipe are opened. So after that, the 3 of them will be running. So from there, we can get the remaining fraction. So the remaining fraction to be filled after 3 hours, we'll get 1 subtract the one that is already filled, which is 3/5, and this will give 2/5. This is what is remaining. And this one is going to be filled by now the cold. After 3 hours, the cold water tap and the drain pipe are opened. So that means the 3 of them will be running, the cold, the hot, and the drain. And we have that in the previous question, that in 1 hour, all of them running will fill what fraction of the tank? We got that one is 4/15. It is here in the first part. 4/15, the 3 taps. So 4/15. So what about this fraction that is remaining? 2/5. How long will it take to fill these? So we get 2/5 times 1 times the reciprocal of 4/15, which is 15/4. So by 5, 1, by 5, 3, by 2, 1, by 2, 2. So this will give 1.5 hours. You get the time in hours, 1.5 hours. So the question is, find the time when the tank will be full. So remember, the time taken will be given by from 7:45 a.m. First, the hot water tap ran for 3 hours. You add 3 hours. And then after that, all the taps running took 1.5 hours. So 1 hour and 30 minutes. So now you add this. So you take 7:45 and then you add 3 plus 1 hour. This will be 4 hours and 30 minutes. And this will give 12:15 p.m. That is the time when the tank will be full. Question 18. Question 18 is on linear programming. A parking lot is to be constructed for X matatus and Y buses. Matatus are allowed 10 meters squared of space and buses 20 meters squared. There is only 500 meters squared space available. Not more than 40 vehicles are allowed at a time. There are always both types of vehicles parked, and at most 15 buses are allowed at a time. A. Write down all inequalities that satisfy the given conditions. So for you to ensure that you come up with correct inequalities, you need to read and understand statement after statement. So let's go to the first statement. A parking lot is to be constructed for X matatus and Y buses. Matatus are allowed 10 meters squared of space and buses 20 meters squared of space. So there's only 500 meters squared space available. So from there, we can get the first inequality. And the inequality will come from the space. So we have X matatus and the space allocated for matatus is 10 meters squared. So for X matatus, if a matatu is allocated 10 meters squared, so for X matatus, you have to multiply that. So you have 10 multiplied by X. So that will be 10x meters squared. Then you're now getting the total space for the matatus and the buses. So for the buses, a bus takes a space of 20 meters squared. So what about y buses? So for y buses will be 20 multiplied by y. So that is 20y meters squared. So this is the total space occupied by x matatus and y buses. And that one should only be, the space that is available for that is only 500 meters squared. So this one should either be less than or equal to 500, because it cannot be more. The space available is 500 meters squared. So it can be less or equal to 500, but it cannot be more. That is the first inequality. Then not more than 40 vehicles are allowed at a time. Not more than 40 vehicles. That means if I take the number of matatus and the number of buses, when I gather sum, it should not be more than 40. Should not be more than 40. So that means it should be less than or equal to 40. That is what we mean by not more than 40. Then there are always both types of vehicles parked. There are always both types. So that means at any given time, there is a vehicle that is parked. That is matatu and a bus. So that means that the buses or the matatus should be greater than 0, because there are always both types of vehicles parked. So at any given time, so the buses and the matatu should be greater than 0. That is the other inequality. Then and at most 15 buses are allowed. At most 15 buses are allowed. So at most means what? For the buses, y at most 15 buses means that the number of buses should be less than or equal to 15. That is what we mean at most. At most 15, less than or equal to 15. Now those are the inequalities that you're supposed to make. Ensure that you make them very well, and you can simplify the ones that you can be able to simplify, like this one, 10x plus 20y is less than or equal to 500. I can simplify that one to give, by dividing all through by 10, I'll get x plus 2y is less than or equal to 50. So after doing that, we go to the next question, which is on the grid provided, draw the above inequalities. You graph them. So we graph them. So to graph them, we'll do these, pick them one at a time. Just pick them one at a time. So like the first one is x plus 2y. The line that you're going to draw there will be continuous, is equals to 50. That is the line. So always work with the intercepts. Work with the intercepts. And work with the intercepts x and y. You just need 82 points to draw, at least 2 points to draw that line. So for example, when x is 0, y will be 25. Then when y is 0 in this equation, x will be 50. So those 2 points are enough. Then I go to the second equation. The line that I'm going to draw is x plus y is equals to 40. So again, here we have when x is 0, y will be 40. Then when y is 0, x will be 40. So the other line that we need to draw is, of course, x is equals to 0 and y is equals to 0. This is the y and the x-axis. No problem with that. And then we have the other one, y is equals to 15. We need to draw that one as well. So now we can proceed and graph. We can graph these. So I can use a scale of 1 centimeter represents 5 for both axes. That will be a suitable scale. So 1 centimeter represents 5. So that I can have 5 there. 10, 15, 20, 25, 30, 35, 40, 45, 50. So this is 5, 0, 10. This is 15. 20, 25, 30, 35, 40, 45, 50, 55. So the first line, x plus 2y is equals to 50, 0, 25. That is the first one I need to plot, 0, 25. So 0, 25 is there. And then we have 50, 0. 50, 0. That is the line, and the line is continuous. That line is continuous, so it runs further from this point, that point. So that is the line. So this line is x plus 2y is equals to 50. Now, first of all, we need to know the side that we're going to shade. So this is how we determine. Remember, the equation of that line is x plus 2y is less than or equal to 50. So I can choose a point on either side and then test. Like I can choose 0, 0. When x is 0, y is 0, substitute here. You get 0 plus 0 is less than or equal to 50, which is true. It is actually less than. So because that side satisfies, so that means the upper side is there. The upper side is the unwanted side. We do shade the unwanted side. So the point that I've picked on that side, the other side 0, 0, has satisfied these, because 0 is less than 50. So there automatically the other side is the unwanted. That means the point that you take on that side do not satisfy. I can go to the other one. The other one is 0, 40. 0, 40 is here. And then 40, 0. 40, 0 is here. So draw that line as well. So there is the line. So this is x plus y. X plus y is equals to 40. So that is there. And then the next one is x is equals to 0. That is the y-axis, not the x-axis. You don't need to draw that. Then y is equals to 15. And remember here we have y is less than or equal to 15. So the line y is equals to 15 is the line that is that passes through this point. Y is equals to 15. This line, it passes there. So it passes here. So this is the line y. Y is equals to 15. Now, for the other line, I didn't shade. X plus y is less than. Let me test this. X plus y is less than or equal to 40. I can test using the same point, 0, 0. So when x is 0, y is 0. So you can see this side also satisfies with that. So it means the other side I'm supposed to shade. The unwanted side is still that side, the upper side of that line. So even for that line, supposed to shade that side. And then the other one is y is equals to 15. So the side that is required is the less than 15. So that means the upper side. We don't need the upper side of that line. The upper side of that line is greater than 15. So we don't need that. We don't need that. That side is greater than. We need the side that is less than, which is below the line. Now you can see we remain with this area here. This is the required region, and this is where we are going to get the points. So now we have represented all the inequalities and shaded the unwanted side. we require maybe to get now maximization for the other part. So we have the required region here, the unshaded one. So part C, the parking charge of matatu is 50 shillings, and that of a bus is 200 per day. Find how many vehicles of each type should be parked on the lot in order to obtain a maximum income that we need to maximize. So to maximize, we need the objective function, and the parking charge for a matatu is 50. So that means for X matatus, it will be 50X. Then the charge for a bus is 200. So Y buses will be 200Y, that is a total, and that will give the charge. This is called the objective function. Now we need to get the number of buses and the number of matatus that will give us the maximum income from this objective function. And we do this. We can use several ways to obtain these. We can use the search line, or we can use the inspection method. So how do you inspect? I want us to use the inspection method. Inspection method is where you test the corner points of the required region. The corner point of the required region. So look at this, the corner points we have, like you can just test several. We have 40, 0. We have another corner point here. So let me highlight the corner point. So you have these is a corner point. But this one, because it lies on the x-axis, the x-axis is supposed to be broken. Indeed, this is supposed to be broken. Then we have another corner point. Actually, this one, this is the one that I can see very well where the lines are intersecting. So this is 30, 10, 30, 10. And then we have the other one, which is here. This one is this one is another one. This is 2015. This point that is here, 2015. So you can test at least 3 points. At least 3 points are okay. I don't see whether we have another one. So we will test these ones. But this one for 40, 0, that one you can leave it, because look, for the x-axis, the equation was greater than. For both axes, x is greater than. So those lines are supposed to be broken, and you don't pick points that lie on the broken line. So that is why it's good to test these ones. So this point and this point here, at least those ones, when you test those ones, we can get the solution, the one that will give us the maximum. So you test the corner points of the required region. So we have 50. The first point, x is 40. And then 200, x is, y is 0. So what profit do we get there? This is a calculator. This will give 2,000. That will give 2,000. Yeah, then the other one, 2015. So 50. And we have 20. 30, 10. We have 30, 10. I think the 30, 10. Let me start with go to 30, 10. So x is 30 and y is 10. So this will give 1500 plus 2000. That will be 35. And then we have 2015. So 50. And then you have x is 20. We are substituting this one now. Plus 200. We have 15. So this will give 1000 plus 3000. So that will give 4000. So after testing the corner point, make sure you test at least 3 points if possible, or use the search line. I have made other videos on how you're supposed to use the search line. You can search and you'll find them. And that is just one of the other ways that you can use in case For the search line, you may not be able to get the points clearly. So, which one gives the maximum? It is this one that has 4,000, and that is when we have 20 matatus, and 15 buses. So how many vehicles of each type? So it is 20 from these 20 matatus and 15 buses. That is how you're supposed to solve that question. Question 19. Below is a sketch area bounded by the curve y is equals to x squared plus 3, and the lines x is equals to -2, x is equals to 4, y is equals to 2x plus 11, and y is equals to 0. So the diagram is there. Part A, fill the table below. Supposed to fill this table. Now filling this table is quite easy. You only need to use your calculator very well and substitute these values of x. I'll just demonstrate using the first one, and then I'll fill the others because I've already done that. So the first one, like for example, when x is equals to -2, you just fill the value of y. So to get y is given by x squared. So substitute x with -2. So that will be -2 squared. Then plus 3. Like that. So just feed that on the way it is in the calculator. Be careful about the negative so that you don't leave. You have to enclose that -2 in the bracket so that you don't find yourself squaring only 2 and leaving the negative. So this will give you 4 plus 3. So that is what you're supposed to do for all the others. Simply substituting the value of x in that function. So when you do that, this is what you're going to get. So you get 7, then this one will give you 4. Then for 0 you'll get 3. Then for 1 you get 4. Then for 2 you'll get 7. Then for 3 you get 12. And then for this one you get, for 4 you get 19. So that is what you do. You get 1 mark for that. We go to part B. Estimate the area of the unshaded region using the trapezium rule with 7 ordinates. Estimate the area of the unshaded region. So you can see the unshaded region there. It is there. And you're supposed to use the trapezium rule with 7 ordinates. So let me first indicate these. This is 0. This interval, this is 1, -1, then this one is 1, this is 2, this is 3, and then you have 4 there. So I can also indicate these heights. Good to show these heights here. These are the ordinates that you're going to use. And then you have the other one there. So we need the area of the unshaded region. So to get the area of the unshaded region, you'll get the area under the line. You see the area under that line between -2 and 4. Then you subtract the area under the curve. Y is equals to x squared plus 3. That is what is going to give you the unshaded area. The area under the line between -2 and 4. Subtract the area under the curve y is equals to x squared plus 3 between the same limits, -2 to 4. So let's first get the area under the line. Area under the line. So area under the line. So area under the line. And the line is y is equals to x plus 11. That is the line. So when you look at that area, this is a trapezium. Look at these points. I will name this trapezium so that you can see it, can be able to identify it. So this is A. Use a different color here. So this is A, this is B, this is C, this is D. So that is a trapezium. This one is a trapezium. And so it will be very easy to get the area under that line. So to get the area of the trapezium, you get it by area is equals to 1/2 times the sum of the 2 parallel sides. the two parallel sides will be these, this one and this. And remember, when x is -2, when x is -2, this height is 7. The height is 7 from what we have here. And then when x is 4, the height is 19. So you can see it there, is 19. So the two parallel sides are 7 plus 19. Then times the height. The sum of the two parallel sides times the height. The height will be now this distance from -2 to 4. That interval from -2 to 4. You can even count. This is 1, 2, 3, 4, 5, 6. That is 6 units. So from -2 to 4, 6 units. So 4 subtract -2. Those are 6 units. So the height will be 6. So this will give you the area under the line. And when you work out this one using a calculator, this one will give you 78 square units. 78 square units. Now after getting that, now we get the area, and that is why you're going to use the trapezium rule, the area under the curve, the area under this curve. Y is equals to x squared plus 3. So how do we get the area under the curve? The trapezium rule. This is the trapezium rule. I have height, then we have y0 plus yn plus twice. I just summarize this one by sum of the middles, or the middle heights. So whereby this will be y0, this will be y1, y2, y3, y4, y5, y6. So just look at this. You are asked to get the area using the trapezium using 7 ordinates. So how do you get the 7 ordinates? You need to know the interval. So what height are you going to use? What is the interval? So to get the height or the interval that you're going to use, you get the difference from -2 to 4. From -2 to 4. So get that difference. So this is 4, subtract -2. Then divide by, you're required to use 7 ordinates. And so 7 ordinates, you're going to subtract 1 and divide that by 6. Why subtract 1? Because the number of intervals, the number of intervals is equals to the number of ordinates. Number of ordinates subtract 1. Why? Because look at these, the intervals. These are the intervals, these spaces from -2 to 4. The intervals 1, 2, 3, 4, 5, 6. So there are 6 intervals. When I'm counting the intervals, I'm counting these spaces from -2 to -1. That is one interval. From -1 to 0, that is another interval. From 0 to 1, that is another interval. From 1 to 2, that is another interval. So there are how many intervals? There are 6. So to get the number of intervals, that is why I've divided by 6. I've taken the ordinates, I've subtracted 1. So this will give me the height, and the height will be 1. So now get the area. The area will be half times 1, do not make any difference. And then y0 plus yn. Y0 is 7. And then the last, yn is the last one here is 19. Like that. Then plus twice the sum of all the other middle terms from 4. So you have 4 plus 3 plus 4 plus 4 plus 7 plus 12 plus 7. So 4 plus 3 plus 4 plus 7 plus 12. Like that. So I've included everything. So this one will give, this is a half multiplied by 7 plus 19, that will give 26, plus twice this. We have 7, 4 plus this 7, 11, this will be 18, this will be 30. So 2 times 30, that will give 60. Like that. And this will give, that is 20 plus 60, that will give 86. 86 divided by 2, That will give 43. So 86 divided by 2, that will give 43 square units. So that is the area under the curve by use of the trapezoidal or the trapezium rule. Now we get the required area. Remember, we are getting the area of the unshaded part. We said we are going to get the area under the line, which is 78 square units. Then subtract the area under the curve, which is 43. And these will give 5. And this one will give 35. So the solution there is 35 square units. So that is the solution for that part. We go to the next part, but see, find the area of the shaded region using integration. The shaded region using integration. So identify the shaded region is the area under the curve. So using integration, because you can see you have no area that is below the x-axis, so you can integrate that one directly from -2 to 4. From -2 to 4. So you integrate from -2 to 4. Then the function of that curve is y is equals to x squared plus 3. X squared plus 3. With respect to x. So when you integrate these, you'll get x cubed divided by 3 plus 3x plus c. So this is -2 to 4. So from there, you just substitute 4. So this will be 4 cubed divided by 3 plus 3, 4. You can leave c because it will get subtracted. Then you subtract -2 cubed divided by 3, then plus 3 -2, and this one will give 64 divided by 3 plus 12, then subtract -8 over 3, and then this will be subtract 6. So when you compute this one using our calculator, 64 plus 12 brackets, then subtract -8 over 3 minus 6. This will give 42. This will give 42 square units. So that is the area using integration. Now we go to part D. Part D, find the area of the shaded region using the mid-ordinate rule with 6 strips. The mid-ordinate rule using 6 strips. So how is the mid-ordinate rule? This is the mid-ordinate rule. Area using the mid-ordinate rule is height multiplied by the sum of the ordinates. The sum of the ordinates. Now we need to get the height or the interval that we're going to use. How do you get the height? Because we're dealing from -2 to 4. So you get the difference of the intervals, and then you divide by the strips, and this will give you 1. Using the mid-ordinate rule, let me take you to the diagram. We're going to extract some other heights that you're going to use, and these are the heights. Mid-ordinate rule. For each of these, look at the diagram that we have here. For each of these strips, so we have one strip from -2 to -1. That is one strip. So we will simply get the midpoint of that strip. Then the other strip from -1 to 0, we also get the midpoint of that strip. Then from 0 to 1, the midpoint of that strip. The other one, the midpoint of that strip. We use the midpoint. The other one, the midpoint of that strip. And the last one there. So you can see we have 1, 2, 3, 4, 5, 6. So now we extract these. So between -2 and -1, so that one we are going to have, the height will be 0.5, -0.5. So the first one will be -0.5. And then the next one the midpoint of from negative 1 to 0. The midpoint there will be negative 0.5. Negative, okay, I saw these. The first one was negative 1.5, I'm sorry. The first one was negative 1.5. So this is negative 1.5. The one that is between, exactly between negative 1 and negative 2, these two. Then the next one now from 0 to negative 1, that is when you have negative 0.5. Then the next one is from 0 to 1, the midpoint there is 0.5. Then the next one is from 1 to 2, that is the midpoint is 1.5. And then from 2 to 3, the midpoint there, 2 to 3, we have 2.5. And then the next one is from 3 to 4. 3 to 4, that is 3.5. 3.5. So that is what you do. You simply extract the midpoint of each of these strips. You get these heights. So every strip, so from negative 2 to negative 1, that is one strip. You get the midpoint of that. From negative 1 to 0, that is another strip. Get the midpoint of that. And from 0 to 1, and so on. So after getting the heights, now you use this equation to fill this table. So again, I will demonstrate using the first one, and then we'll fill all the others. So when x is equals to negative 1.5, y is x squared. X is negative 1.5. Just put it the way I fill it in the calculator, the way it is, using the brackets, very important. And then plus 3. So when you feed that on the calculator, that is brackets negative 1.5, close the bracket, and then you square that, and then you add 3. Add 3 to the answer, you get 5.25. You get 5.25. So that is what you're supposed to do, 5.25. So you do the same for all the others. So allow me to fill the others. I've already filled mine here. So when x is negative 0.5, I have 3.25. Then when it is 0.5, x will be 3.25 again, 3.25. When x is 1.5, y will be 5.25. And then when x is 2.5, that one will be 9.25. Y will be 9.25. And the last one, when x is 3.5, this will be 15.25. After doing that, now we can use the formula and work it out. So we have area is equals to height, which we got as 1, then times the sum of all these ordinates. So 5.25 plus 3.25 plus 3.25 plus 5.25 plus 9.25 plus 15.25. So you add all these using a calculator. So 5.25 plus 3.25 plus 3.25 plus 5.25 plus 9.25 plus 15.25. So you get 41.5. So this one gives you 41.5. You get 41.5 square units. Question 20. P and Q are 2 points on latitude 40 degrees north. Their longitudes are 30 degrees east and 150 degrees west, respectively. Find to one decimal place. Take the radius to be 6371 and pi to be 22/7. A, the distance in kilometers between P and Q along the parallel of latitude. So that is the first question. So let me begin by sketching these positions. So I'll begin by sketching. So both of them are 40 degrees north of the equator. and one is P is 30 degrees east. So this is just a sketch, 30 degrees east. So that is where we have P, and then Q is 150 degrees west. 150 degrees west. Remember, this is just a sketch. 150 degrees west. So this is where we have Q. So this is the distance that you require to get along the parallel of latitude, and you're supposed to get that distance in kilometers. So how do you get this distance along the small circle in kilometers? So distance PQ is given by, take the, because you can see they are both on the same latitude, so you get the longitude difference divided by 360 multiplied by 2 pi r cosine of the latitude angle. So we get the longitude difference. So longitude difference, one is 30 degrees east, the other one is 150 degrees west. So the longitude difference will be 30 plus 150, and this gives 180. So 180 degrees is the longitude difference divided by 360, then multiply by 2 times pi times the radius of the earth, which is given as 6371, times the cosine of the latitude angle, 40 degrees. So just use a calculator to work out this. Remember, you're supposed to give the answer correct to one decimal place. So this one will give 15,338.6 kilometer. That is correct to one decimal place. So that is all about part A. We go to part B, the shortest distance along the Earth's surface between P and Q in kilometers. The shortest distance. Now, which is the shortest distance between P and Q? It is distance through the center of the Earth. So if I draw the equator here, we draw the equator, and then I have the center. This is the center of the Earth. There's an angle that you're going to get here between P and Q when the distance is via the center of the Earth. So because the two places are 40 degrees north, so this angle here will be 40 degrees. P is 40 degrees north of the equator. Then Q is also 40 degrees north of the equator. So this being a straight line, now you get the angle between the two places. The longitude difference now will change. It will not be 180. It will be the angle between here. These are straight lines, so this 40, 40. Remember, this one should add up to 180. Sum of angles on a straight line. And so this one will be 100. So now when you're calculating the shortest distance, we're going to use this formula. Theta over 360, 2 pi r. That is how we get the distance along the great circle. 2 pi r. So therefore, the angle is the one that is changing. Now the longitude difference will be 100 degrees, the angle at the center here. And we got it after considering this angle. P is 40 degrees north of the equator, so this angle is 40, this one is 40. So the angle between there is 100 to make this the sum of the angles here on this straight line to be 180. So this will give 100 degrees divided by 360 multiplied by 2 times pi, which is 22/7, times the radius of the earth, which is 6371. And when you work out this one using the calculator, you will get this one to be 124.0 kilometers. You can see when you compare the two distances, distance along the parallel of latitude is 15,338.6. Then you can see the shortest distance. You can see this one is shorter. So that is how you're supposed to work out that. Then you go to part C. So a weather forecaster reports that the center of a cyclone at 40 degrees north, 60 degrees west is moving due north at 24 knots. How long will it take to reach a point 45 degrees north, 60 degrees west?
So the first thing is to know which distance is this. It's moving from this point due north. So if I simply draw a rough sketch here. So one is so is here 40 degrees. So that is a 40 degrees north, and this is a 60 degrees west. So this is the point. So it is moving from these. I want you to look at that distance. It is moving due north. So meaning it will move along that longitude at that speed that is given. So moving due north from this point means that it will move. It will follow the longitude. It will be distance along the longitude or the distance along that meridian, and that is distance along the great circle. So because you're given the speed in knots, automatically you will get and it is going to, let me first it is going to another point that is 45 degrees 45 degrees north. That's it, is going to this. So you can see this distance here. This is the distance. This distance is a distance along the great circle. So how do you get the distance along the great circle in nautical miles? We get it by, so distance along the great circle in nautical mile is given by 60 theta, whereby theta will be the latitude difference. You can see both of them are on the same longitude, so we will get the latitude difference. So theta will be the latitude difference. So look at this, 45 degrees north, 40 degrees north. Both of them are to the north, so to get the difference, you simply take 45, subtract 40. So the latitude difference will be 5. So therefore distance will be 60 times 5, which gives 300 nautical miles. So that is how you're supposed to get the distance. Now, because you are required to get how long will it take to reach this point, that is time. You're supposed to get how long, that means time. So how do you get time? We get time by taking distance divided by speed. And this will be, distance is 300 nautical miles. And then the speed is 24 knots. So when you work out these, you'll get the answer in hours. You get the answer in hours. Distance in nautical miles divided by speed in knots, and this will give you 12.5 hours or 12.5 hours. So that is how you're supposed to get the solution for that part. There we go, part D. A plane leaves P at 2:15 at a speed of 350 knots to town R, 40 degrees north, 65 degrees east. Determine the time at R when the plane arrived. Determine the time at R when the plane arrived. So you notice, let me first indicate the coordinates of P. So P is 40 degrees north and 30 degrees east. Then Q is 40 degrees north, 65 degrees east. They are all here. Not Q, but this is R. I'm sorry, this is R. This is R. So R is 40 degrees north, 65 degrees east. So it is here, R is here. Then P we have it there, it is up here. So we had P there, the first part of the question. So because you can see we are moving from one longitude to another, from P, when it is 2:15 at P, 2:15 p.m. at P, we need to get the local time at R first. That is the first thing. Before we proceed and calculate the time that it arrived, we need first to consider that there will be time difference because of differences in longitudes. When you're calculating time, we use the longitudes, not the latitudes. So you're going to consider the longitudes. So first let us get the local time at R when it is 2:15 p.m. at P. So we first get the longitude difference. So the longitude difference, one is 30 degrees east, the other one is 65 degrees east. So you subtract 65 minus 30. So this one will give 35 degrees. Then this longitude difference as time difference by the fact that 1 degree has a difference of 5 minutes. So what about 35 degrees? What time difference will that one bring? So it will be 35 multiplied by 4. And 35 multiplied by 4, this will give 140 minutes. 140 minutes is the same as 2 hours and 20 minutes. So that means the time difference between these two places, P and R, is 2 hours, 20 minutes. Now we need to know which place between P and Q, P and R, which one will be ahead of time and which one will be behind. So when you look at 30 degrees east and 65 degrees east, 65 degrees east is more to the east of the prime meridian as compared to 30 degrees east. So that means that 65 degrees at this point at R will be ahead of time. It will be ahead of time. Then 30 degrees east is more to the west of the prime meridian. If we look at the prime meridian, so actually when you draw and sketch these two places, P and R, you'll see which one is more to the east of the other, and definitely it is point R. So because of that, so since R will be ahead of time, we will add, so the local time at, so time at R will be given by 2:15 plus we add 2 hours 20 minutes. So this will give 4:35 p.m. So that is the local time. Now after that, now we can proceed and get the time difference and the time taken. Time taken to travel from P to R, we can get that time because you are given the speed. So we can get the distance. So we can begin by getting the distance taken from P to R. So time taken now, we need distance, because we need distance divided by the speed. We have the speed, so we have the speed in knots, so we need to get the distance in nautical miles. So look at these two places. Identify which distance is this. This again is distance along them. It is distance along the, let me see whether it is along the great circle. It leaves P and heads down R. So when you sketch these two places, they are on the same latitude, 40 degrees north, but different longitudes. So if I sketch, let me just sketch here that I can show you clearly. So both of them are 40 degrees north, and one is 30. So 65 degrees. P is 30 degrees east. 30 degrees east. So P is there, and then the other one is so let me draw these on properly because both of them are to the east. So one is there, and then the other one is there. So this is 65 degrees east. Just a sketch. This is just a sketch. So this is R. R is here, and then this one is 60. Not 60, but 30. This is 30 degrees east. So we have P being here. So you can see the plane leaves P. It leaves P. So look at this distance. It leaves P and goes to r. So this distance, that distance in nautical miles, and you're given the speed. So definitely this distance is distance along the small circle or the parallel of latitude. That is the distance PR. PR is distance along the parallel of latitude. So we need to get that distance in nautical miles. So how do you get the distance in nautical miles? So distance will be given along the parallel of latitude, 60 theta cosine of alpha. And theta is 60. Theta is the longitude difference between these two places. So 65 degrees east, we got it here. His longitude difference is 35. So you multiply by 35, and then you multiply by the cosine of the latitude angle. They are lying on the latitude 40 degrees north, so the latitude angle is 40 degrees. So work out that. So this will give 60 times 35 times cosine of 40. So this gives 1608.7 nautical miles. 1608.7 nautical miles. So that is the distance. Now it is easier to get the time taken. So now time taken will be given by distance, which is 1608.7 nautical miles. Then you divide by the speed in knots. The speed in knots. So that will give the time in hours. The time taken in hours. The time taken in hours. So that is what I want to get. So you divide this 1608.7, then you divide by 350 knots. So this gives we are getting 4.5. Actually it's giving 4.5. If we round off this one correct to 1 decimal place as required in this question, this will give approximately 4.6 hours. 4.6 hours. So that means now 4.6 hours is the same as 4 and 3 over 5. These are 4 and 3 over 5. And if you convert this, we convert this one to minutes, hours and minutes. 3 over 5 times 60. This will give 36. So equivalent to 4 hours and 36 minutes. So that will be the time taken. Now after getting that, now the arrival time, we take 4:35, the local time at R. So arrival time will be the local time at R, which is 4:35, then add 4 hours, 36 minutes, like that. So this will give 71, because you subtract 60. You're going to subtract 60. You need to be very careful with the questions on time. So you get 71, but of course you have to subtract 60, and that one you'll be left with 11. So you'll be left with 11 here, and then you will have 1 hour taken to this side. So this is 4 plus 4 plus 1, and that will give 9. So from 4:35 p.m. it will arrive at 9:11 p.m. 9:11 p.m. Question 21. The diagram below is a right pyramid VABCD. The base is a square of 10 centimeters each side. Vertex X is vertically above the center O. VA is equals to VB is equals to VC is equals to VD is equals to 9 centimeters. So all the slant heights are equal. It is a right pyramid. That is what it means. All the slant heights are equal. Point P and N are midpoints of VO and AB respectively. So you can see them. So you can see point in the diagram point P and N is supposed to be here. Actually, N is supposed to be here. So that is the midpoint of VO and AB respectively. So find the angle between, first question, VA and VC. That is the angle between a line and a line, VA and VC. So we go to the diagram, VA, and see line VA and VC. So the angle that we need is this angle that is between here. That is the angle between those lines, VA and VC. So if I can draw that triangle that I'm going to use, it looks like this. The triangle that I'm going to use in order to get that angle will be like this. So that is the triangle, and then I will need to bisect that. So this is a V, C, and A. So we want the whole of this angle. Between VA and VC, we need the whole of this angle. So if we get this one angle here, it is the same with this one. So we just multiply it by 2. So when we drop a perpendicular from V to meet CA, so that means we need to get CA, and it is possible to get CA because this is a square. So this is 10 and this is 10, and this angle is 90 degrees. So it is possible to use Pythagoras theorem and get CA. So CA will be given by Pythagoras theorem, 10 squared plus 10 squared, which will give the root of 200. The root of 200. And what is the square root of 200? The square root of 200 is 14.14. 14.14 centimeters. So that means the midpoint CO, this will be half of that, will be 7.07. 7.07. That is half of 14.14. So now after getting that, we have VC. VC is 9 centimeters. So this is 9 and this one is 9. So now it is possible to get the angle, this angle, using I can use trig ratios to get that. So the best one to use here is sine. So sine of angle theta is given by the opposite, 7.07, divided by the hypotenuse. So angle theta will be given by sine inverse of 7.07 divided by 9, like that. So that is what you're supposed to do. So I get this 7.07 divided by 9, like that. And then you get the sine inverse of that. So this one gives 51. You'll get 51. So this will give 51.77. And since we want the whole of this angle, so one of these angles, theta, is 51.77. So now the whole of that angle, we have to multiply that by 2. And now we get the required angle. So that will give 103.54 centimeters. So that is how you're supposed to solve that part. We go to part B. PN and the plane ABC. PN and the plane ABCD. PN. So we go to PN. So where is PN? PN is, so we have PN, you can see that line, and then the plane ABCD. So we have this plane that is here. So that is the angle between a line and a plane. And how do we get the angle between a line and a plane? We get it by getting the angle between that line, which is PN, and its projection on that plane. So what is the projection of PN? Projection of PN on the base, that is ABCD. the projection of Pn, or the shadow of Pn on the plane ABCD is NO. NO. So NO is the projection of Pn. So that therefore the angle would be between that line Pn and its projection ON. And that angle is the one that we have here. So this would be the angle. So using that diagram, we will be able now to get this distance. You can see NO is half the distance of CB. So if CB is 10 centimeters, then NO will be 5. So that would be 5. And then, given that P is the midpoint of VO. So we can get that. We can get VO. So it is possible to get VO. So we can get VO. I think now if we manage to get VO, it will be better that way. So VO, let me see how we'll get VO. Now, it is possible to get VO because I will simply use VCO. So using triangle VCO, that is 90 degrees at that point. And this is 7.07, and then this one is 9. So VO will be given by the square root of, this is Pythagoras theorem, 9 squared minus 7.07 squared. That is what is going to give VO. So let us work out these. So 9 squared minus 7.07 squared. So 9 squared minus 7.07 squared, then you get the square root. That gives 5.5. So I'm getting 5.569 centimeters. That is the vertical height VO. Now, given that P is the midpoint of VO, therefore it means that PO will be 5.569 divided by 2. And when you divide that one by 2, this one will give 2.785 centimeters. So now having that, now it becomes very easy for us to proceed after getting PO. So we have now these ITS. So this is 2.785. So for that triangle, now if I extract that triangle, let me extract that triangle here. So let me extract the triangle. So that is O. And then we have P and N. So we have P and this is P and this one is N. Remember, we require this angle, and PO is what we have obtained. This is what we obtained at 2.785. And then ON is 5. Like that. So now getting the angle will be very easy. So we use tangent. So tan of angle theta is equals to opposite 2.785 divided by the adjacent. So theta will be given by the tan inverse of 2.785 divided by 5, which gives, that will give, so you simply get the tan inverse. So the tan inverse of 2.785 divided by 5. So you get the angle is 29.12 degrees. So that is how you solve that part. We can go to the next part, which is part 3. the planes VBC and ABCD. That is the angle between two planes. Plane VBC, get the diagram. VBC, you can see that plane, and the base. So how do we get that? To get that angle, let me draw some lines. So these will be the angle. So the plane VBC. So I'll draw a line from that to the midpoint, and then from that point all the way to the center. So the required angle will be this angle. That will be the angle between the plane VBC and the base. So you simply draw a line from V to meet line CB at 90 degrees. It should be perpendicular. And then another line from this point, from the center, which is perpendicular, where the two lines are intersecting, where these two lines are intersecting. That is the angle that is required. So this is the angle that we need. So very quickly identifying the side. So you can see from this point, these will be 5. That distance from this point to the center, that will be 5. And then we have the height. We already have the height, VO. So I can extract this triangle. The triangle that I have formed there is triangle VMO. So let me extract it here. VMO. So VMO. So that is O, V, and this is M. So this is the angle. Take you to the diagram again. Look at that diagram, VMO. So we have VO. VO, we got it easier. 5.569. 5.569. And then MO. So that we have MO. MO is 5 centimeters. That is 5. So it is possible to get that angle. So now getting the angle, we use trig ratios, opposite of adjacent, we use tangent. So tangent of theta is equals to 5.569 divided by 5. So theta therefore will be the tan inverse of 5.569 divided by 5. As simple as that. And this will give, so we get the tan inverse of 5.569 divided by 5. So that gives 48.08. 48.08 degrees. So that is the way you're supposed to solve that part. We go to the last part. Find the length of line PN. The length of line PN. So look at where PN is. So let me take you to the diagram. So PN is here. So this is the line PN. That is the line that you need to get. So it is very easy if I extract this triangle PON. So let me extract it here. PON. Triangle PON. So here it is. So we have PON. So P is here. Then O is here. And then N is here. So it is 90 degrees at that point. So this is PO. We got PO as 2.785. 2.785. And then we have ON. ON as 5. So now getting PN, Pythagoras theorem, we use Pythagoras theorem. It will be 2.785 squared plus 5 squared. Get the square root of everything there. So this will be, so you're getting the square root of 2.785 85 squared plus 25, that is 5 squared. When you get the square root of that, this is going to give 5.723 centimeters. And that is how you're supposed to solve that question on three-dimensional geometry. Question 22. An arithmetic progression of 41 terms is such that the sum of the first 5 terms is 560 and the sum of the last 5 terms is negative 250. Find A, the first term and the common difference. The first term and the common difference. So looking at the information that you are given already, it is here. You have the 41 terms. And then you're given the sum of the first 5 terms. The sum of the first 5 terms. And this one is an AP, arithmetic progression, 560. Then the sum of the last 5 terms is 250. So how are you supposed to continue with this question? Now the first thing, get the sum of the first 5 terms. Of course, you know how to get the sum of a number of terms in arithmetic progression is supposed to be given by n divided by 2. Then you have 2a plus n minus 1 d, where n is the number of terms, a is the first term, and d is the common difference. So now since we are given the sum of the first 5 terms is 560, so we take 560 is equals to n. N will be 5 because it is the sum of the first 5 terms. So n will be 5. So this will be 5 over 2, like that. And then 2a, we don't have a, then n minus 1, that is 5 minus 1, this will give 4d, like that. So this will give 560 is equals to 2.5. Then we multiply by 2a plus 4d. Now after we've done that, now from there we can simplify these. So if you simplify these, 560 is equals to 2.5 times 2, that will give 5a. Then 2.5 times 4d, that will give 10d. 10d. So that is the first equation. Now where do we get the other equation? We get it from the other statement here. The sum of the last 5 terms is negative 250. So which are these? How do we get the last 5 terms? Since you are given these are 41 terms, then it is possible to extract the last 5 terms. So the last term, which is 41, the last term is 41. And how do we get the 41st term? It is given by a plus 40d. Remember the nth term. The nth term of an arithmetic progression is given by a plus n minus 1 d. So if you want to get the 41st term, you simply substitute n with 41. That is why you are getting a plus 40d. So that is the last one. So the other one that follows is the 40th. The 40th will be a plus 39d. Then the 39th term, that will be a plus 38d. Then the 38th term, it will be a plus 37d. And then the last one, which is now 37th term, it will be a plus 36d. So this is what represents the last 5 terms. So when you add the last 5 terms, so that means if I take all these and I add them together, if I take a plus 40d plus a plus 39d plus a plus 38d plus a plus 37d plus a plus 36d, these should give negative 250. Negative 250. That is what you're given in the question. So now we add everything here. When you add all these a's that are here, when you add all those a's, you get there are 5. There are 5 A's. So 1, 2, 3, 4, 5. Then when you add all the D's, 40D plus 39D plus 38D plus 37D plus 36D, we add them together. So you have 40D plus 39 plus 38 plus 37 plus 36 plus 36. That one gives 190D. 190D. That should give negative 250. Now, when you look at what we have already, we have 2 equations. So we have 2 simultaneous equations that we can now solve. We have that one and we have these. So once we solve them simultaneously, it is possible now to get the value of A and D. So we have the first equation is 5A plus 10D is equals to 560. So solve those 2 equations simultaneously, the 2, 1 and 2. So you want to eliminate these are 5A, so you subtract the 2, 5A minus 5A, that one is gone. 190D minus 10D, this will give 180D is equals to negative 250 subtract negative 250 subtract 560, that gives a negative 810. Negative 810. So D will therefore be negative 810 divided by 180. And this one will give, when you divide these, 810 divided by 180, that gives a 4.5, negative 4.5. That is the common difference. Then from there you simply substitute. You can simply substitute now this value of D in any of these equations. I will substitute it in the first equation. First equation is 560 is equals to 5A plus 10D. D is negative 4.5. Like that. So now from here you can get the value of A. So when you make A the subject, make A the subject there. So when you make A the subject, this will give 5A is equals to, this will be 560 minus 45. 560 minus 45. Then you divide by 5. Let me repeat this again. So let me see. So I'm trying to substitute here. So D is negative 4.5. Negative 4.5. So that means, oh, I'm supposed to add here. That is why I'm getting a different answer. So this would be 560 plus 45. And then you divide by 5. You get 121. So A will be 121 and D negative 4.5. So after getting that, we have answered that question. The first term and the common difference is there. We got part B, the last term. So which is the last term? Now when you look at this question, the last term is 41. Is here the 41st term. That is the last term. So last term is equals to 41. And how do you get that? A plus 40D. So this one we have A is 121 plus 40. D is negative 4.5. So 121 plus 40, then multiply by negative 4.5. So that gives negative 59. Then the last question, the sum of the progression. This progression is arithmetic. So how do you get the sum? The easiest way to get the sum. How do we get the sum? Now, the easiest one, you can use this formula, the one that we wrote here. the first one here, because you have everything. You have the last term, you have the number of terms is there, you have the first term, but that one is quite a longer route that you're going to follow. Since you have the first term and you have the last term, you have the first term as 121 and you have the last term as negative 59. You can use this formula that involves the first term and the last term. So n divided by 2, then the first term plus the last term. That is the easiest when you have the first term and the second term. So you can simply use these, and of course you have the number of terms. The number of terms is 41, so just substitute. So 41 divided by 2, then the first term is 121 plus the last term, which is negative 59. As simple as that. So this will give 41 divided by 2 multiplied by 121 subtract 59. This gives 62, and this will give 41 times 31, 41 times 31, and this will give 1271 as the solution. And that is how you're supposed to solve that question. Question 23. There are two bags A and B. Bag A has 4 white balls and 6 red balls. Bag B has 2 white balls and 3 red balls. Each bag has an equal chance of being picked. If a bag is selected at random or randomly and 2 balls picked with replacement in bag A and without replacement in bag B, find the probability that A, they are both white. Find the probability that they are both white. So 2 balls are picked. So we have 2 bags, and each bag has an equal chance of being picked. So that means when you draw the tree diagram, I will draw it like this, whereby this will be bag A and this will be bag B. Because they have equal chance of being picked, they will be, the probabilities will be represented by half-half. So that's the first thing. How many balls are picked? So we have 2. A bag is selected and 2 balls are picked. So that means we'll have 2 branches after this first branch. The first branch will be represented by the probability of picking each bag, which is a half. Now let's go to bag A. Bag A will come here. So bag A will come here, and it has 4 white balls and 6 red balls. So that means all the balls are 10, 6 white. So we have white and we have red. So probability of picking white will be 4 divided by the total. The total number of balls in bag A are 10, 6 plus 4, 10. So probability of picking a white ball will be 4 over 10. So 4 over 10, and the other one will be 6 over 10. And then you remember that for bag A, with replacement, so for bag A, a bag is selected randomly and 2 balls picked with replacement in bag A, with replacement in bag A. So that it means that once we pick the first ball, it is replaced, so the total will not change. Once the ball is picked, it is replaced, so the total will not change. But the other bag without replacement, so when a ball is taken, the total will have to reduce because it is not replaced. So that is the first pick. Now the second pick in the same branch will be drawn like this. So this is the second pick now. The second pick, white, red, white, red. And since total is not going to change because it is being replaced, a probability of picking white here will remain to be 4 over 10. This one will remain to be 6 over 10. So this is 4 over 10 and 6 over 10. But now when it comes to the other branch, when it comes to this branch here, we have white and we have red. So the first pick, let's go to the bag B. Bag B has 2 white balls and 3 red balls. So that is a total of 5 balls. So probability of picking a white will be 2 divided by the total 2 over 5. So that is the first pick, 2 over 5. Then now when it comes to the second pick, you need to be very keen here because there is no replacement. So white, red, white, red. So there is no replacement. So that means if you pick, the first pick was white, and then now you proceed again and pick another white. So the whites were 2. So what will remain is 1 white, and then the total will not be 5, it will be 4. There were 2 whites in the first pick, then you picked 1, so now the whites reduced by 1. So from 2 to 1, then the total again changed. So the other one automatically will be 3 over 4. Remember that the total, the sum of the probabilities in every branch should give you 1. 1 over 4 plus 3 over 4. So once you get the first probability, the other one is automatic. We go to the second branch here, where we have red. So you picked red in the first pick. So automatically the whites will not be affected. The whites will not be affected. There are 2 whites, but the total is affected, will be 4. Then the other one will be again, look at these, the first pick red, then the second time you're coming, these will be, look at this, the second time you're picking now the reds were 2, now the reds are going to reduce because you're picking another red. It should be 1 over 4. You see that, So these will be, let me check this one again. Oh, so there were 3. I'm sorry. There's something I noticed here. I did not include the probabilities here. Something. Sorry for that. Now for these bag B has 2 white balls and 3 red balls. 2 white balls. So the probability of picking a white ball will be 2 over 5. That is the first pick. Then the probability of picking a red ball, the reds are 3. So these will be 3 out of 5. So I'm here. So the first pick, you picked reds. Then the second time you're coming and picking again, now the reds are going to reduce. Because the first time you picked a red. So the second time now, the reds are going to be less by 1. So from 3 to 2. Then the total will be affected. The total will be 4. You can see 2 over 4 plus 2 over 4, that gives 1. So that is the probability tree diagram. So from there, you can indicate these probabilities so that it can be easier for you to work them out like this. So let me indicate them like this. This way, it will be very easy for you to, like that. So the first one, from bag A, white, white. From bag A, white, red. From bag A, red, white. From bag A, red, red. From bag B, white, white. From bag B, white, red. From bag B, red, white. From bag B, red, red. So that is the tree diagram. Now let's go to the question. The probability that they are both white. The first one, the probability that they are both white. Probability that they are both white is represented by that one. A, from bag A, you get both are white, and then from bag B, both of them are white. So that will be probability of A, white, white, or probability of B, white, white from bag B. So these will give, so you can follow that branch. From A, we have a half, and then white, white, 4 over 10 times 4 over 10. 4 over 10 times 4 over 10. Or you add, or bag B, half, we are here, a half times 2/5 times a quarter. 2/5 times a quarter, like that. So once you work out these using a calculator, once you work out this probability using a calculator, 1/2 times 4/10 plus times 4/10 plus everything there correctly, you'll get 13 divided by 100 simplified. So that is the solution for the first part. We go to the second one. They are of different colors. They are of different colors. That means all the others that let me see, they have different colors. So we're going to take let me tick them where we have different colors. So like here, white, red, that one. Then the other one is red, white. The one that I'm putting X, that is what we require, different colors. And then we have this one, and then we have this one. Like that. So those ones, you can see there are 4. White, red from bag A, red, white from bag A, then from bag B, white, red, white. Those are the 4 that we need to consider. So these will be given by probability of from bag A, white, red, or from bag A, red, white, or from bag B, white, red, or from bag B, red, white, like that. So from bag A, white, red, from bag A, white, red, that will be a half times 4/10 times 6/10. 4/10 times 6/10. You need to be very careful when you're following the branches that you don't make any error. You need to reconfirm these that I've done. So then the next one, from bag A, red, white, from bag A, red, white. So a half times 6/10 times 4/10. A half times 6/10 times this one, 4/10. The next one, bag B, white, red, so it is here. So this will be a half times 2/5 times 3/4, 2/5 times 3/4, like that, and then plus the last one, B, red, white, so a half, and then red, white will be 3/5 times 2/4, 3/5 times 2/4, like that. Once you've done that, now the rest you do it by use of a calculator. You just compute. So a half times 4/10 times 6/10, that gives 24/200. So this one will give the same, 24 divided by 200. And then the next one will give, when you simplify these, this will give 6/40. And also this one will give 6/40. So everything simplified, 24, you add all these fractions and you simplify, you'll get 27 divided by 50 as the solution for that part. We go to part C. At least one ball is red. At least one ball is red. So what do we mean by at least? At least one is red means 1 being red or 2 being red. So anywhere we have 1 red or 2 of them being red, that is what we need. So there is an easier way of doing this. So anywhere we have 1 red or 2 reds, that is what we need. And there is an easier way of working out this. Let me see. Actually, when you look at this tree diagram, the only instance where we don't have at least one red is only these: A, white, white, and B, white, white. All the others, apart from the ones that I've circled, all the others, there's a place where you have one red and or two reds. So we require to add all these. And to make things easier, because the sum of all these probabilities is going to give us 1, and we got the probability that they are both white. So the only ones that are out of place is both are white, either from bag A, white, and either from bag B, white. So we need to get the sum of all these probabilities, which is 1, and then we subtract the probability that they are both white. We remove the whites. So we remove the probability of A white, white, and B white, which we got as 13 over 100. And now we'll be left with all the others where we have either one red or two reds. So 13 divided by 100. So 13 divided by 100. That is the easier way. And this will give 87 divided by 100 as the solution for that part. The last part, none of the balls is white. None of the balls is white. So go to the tree diagram, none of the balls is white. So that means we need to go to instances where we don't have a white ball. So where don't we have a white ball? So let us identify where we don't have a white ball. So we can check where don't we have a white. We have this one, red, red. You can see that, red, red. And from A and from B, we have red, red. That is what we need. So red, red. So we have a half times 6 over 10 times 6 over 10, because we don't want any place where we have white. None is white. So that means we require the probability from A, we have red, red, there is no white, or from bag B, red, red. That is what we mean by none of them. In those two instances, none of them will be white. So we get the probability. So A, red, red, A, red, red. You can see it is here. It is here. So a half times 6 over 10 times 6 over 10. A half times 6 over 10. A half times 6 over 10 times 6 over 10. That is first one. Then plus B, red, red, B, red, red. So you have a half times 3/5 times 2 over 4. Half times 3/5 times 2 over 4. Like that. So when you work out these, everything here, this will be 36 over 200 plus this will be 6 divided by 40. And when you add that using a calculator, this will give 33 over 100. And that is simply how you are supposed to solve that question. Question 24. A rectangular plot measures 75 meters by 36 meters. A lone rectangular in shape is situated inside the plot with a path surrounding it as shown in the figure below. So you can see the measurements. They are all there. The width of the path is y meters, as you can see, between the lengths of the lone and those of the plot, and 2y meters between the width of the lone and those of the plot. Part A, form and simplify an expression in y for the area of the lone, and the second one, the area of the path. So we start with the area of the lone, a simplified expression. Now, having these dimensions, the rectangular in shape is 75, that is the length, and the width is 36. So we need to get the length of the lone, and since you can see from either side we have 2 meters, 2 meters. So the lone, the length of the loan will be, you'll take 75 and then you subtract both ends. We have 2y meters and 2y meters, that is 4y meters. So that will be the length of the loan. Then the width. The width, for the width, this one will be the width of the rectangle is 36, and then there is this part that is y meters plus y meters, that is 2y. So y meters plus y meters, that is 2y. So you subtract that, you remain with now the width. So having that, now we can get the expression of the area by simply taking the length. So area will be the length, which is 75 minus 4y, and then subtract the width, that is 6 minus 2y, like that. So you expand these, 75 multiplied by 36 minus 2y, then minus 4y. You know how to expand these, 36 minus 2y. So this will give 2700 minus 150y minus, this will give 144y, then plus 8y squared. So when you simplify these, you'll get 8y squared, then subtract 294y plus 2700. That is a simplified expression. Now we go to the path. What is the area of the path? Now to get the area of the path, we shall get the area of the rectangle, and then we subtract the area of the loan. So that is how we get the area of the path. So the area of the rectangle, which is 75 times 36, that is the area of the rectangle, and then we subtract the area of the loan, which is 8y squared minus 294y plus 2700. Now we'll be left with the area of the path. So expand this, so this will be 2700 subtract, we have 8y squared. Remember, when you're subtracting, you have to indicate the brackets here, and all these signs will be affected. So these will be positive 294 when you open the brackets, and then this one will be negative 2700. So now once you get that, you can simplify these, and these will simplify to 294y subtract 8y squared. That is the simplified expression, because you can see 2700 minus 2700, that is 0. So that is what you remain with. Now we go to the next one, part B. The ratio of the area of the path to the area of the loan is 3:2. Form an equation in y, and hence you solve it. So the ratio of the area of the path, the area of the path. So we got the area of the path to be 294y subtract 8y squared. So when you're getting the ratio, then the area of the loan, that one we got it as 8y squared minus 294y plus 2700. So that is the ratio, and that should give you 3:2. So this is what you're supposed, this is the equation you're supposed now to solve, and then that should give you the value of y. So for this one, first thing you're going to do, you cross multiply. So you'll have 2 multiplied by 294y minus 8y squared is equivalent to 3. So you have 8y squared minus 294 plus this 294y plus 2700, like that. So when you open the brackets here, you will get 588 y minus 16y squared is equals to, this will give 24 y squared, then subtract let me see, so is equals to 24, then 800, this will give 882y, and then 3 times 2700, that will give 8100. From there, now what I'll do, I'll try to take the like terms together. I'll take everything that is from the left hand side, I take it to the right hand side, so that I have, so from the right hand side we have 24y squared minus 882y plus 8100, and then I subtract 588y, then negative 16, when I take it to the other side, negative 16y squared, I'll get positive 16y squared. That one should be equivalent to 0. Like terms together, 24y plus y squared plus 16y squared, that will give 40y squared. Then negative 882y, subtract 588y, that will give 1470y, negative 1470y, and then we have 8100. So you can try to see whether it is possible to simplify. They can divide all through by 10. When you divide all through by 10, you get every term by 10, you get 4y squared minus 147y plus 810 is equals to 0. That is a simplified equation. Now from there, the next thing that you're supposed to do is simply use the quadratic formula. You can use the quadratic formula. Remember the quadratic formula. This is the easiest that you can use here. So b squared minus 4ac divided by 2a. So a in this case will be 4. Then b will be negative 147 and c will be 810. So substitute. So negative b will be 147 plus or minus, then b squared, negative 147 squared minus 4 times a, which is 4 times 810, which is c. I'm substituting these. Then everything divided by 2 times 4, that will be 2 times 4, which is 8. So we continue to simplify. So once we simplify everything, I want to simplify everything. So we get 147 plus or minus everything that is under the square root sign here. When you compute that one using a calculator, negative 147 squared minus 4 times 810. That one will give 8649. 8649, and then divided by 8. So this will give 147 plus or minus, the square root of this will be 93 divided by 8. So the first value of y will be 147 plus 93 divided by 8, and here the value of y will be 30, and the second value will be y is equals to 147 subtract 93 divided by 8. So here the value of y will be 6.75. So you have these two values. So solve for the value of y. So you got the value of y. Now we can go to the last question, the perimeter of the loan. The perimeter of the loan. Now remember, the length of the loan was 75 minus 4y, and then the width was 36 minus 2y. It is up here. It is up here. We got it here. It is up here in the first part. So now we can try to substitute these values of y and see which one will give us the correct measurement. When I look at the one that is 30, if I try to substitute 30, y to be 30 in the measurement for the width, you notice that that one will give us a negative width. 36 minus 60, that will give. So we are going to ignore y is equals to 30 because that one gives us a negative value for the width if substituted there. So we remain with 6.75. So the new length will be 75 minus 4, and these are y is 6.75. So this one will give, when you do that substitution, that will give 48. When you substitute for the width, that is 6, subtract 2, 6.75, that one will give 22.5. So now you have the length and the width. So the length of the lawn is 48 meters, the width is 22.5 meters. So the area, or not the area, but you're supposed to get the perimeter. So the perimeter will be given by 2 into length plus width. So this will be 2. The length is 48 meters. The width is 22.5. So once you work out this, you will get this one to be 141 meters as the perimeter.